morning, class, and welcome. Today is Wednesday, April 22nd, and let's get started. So we are doing our black diamond, which you'll see up on our screen. Now, we're still focusing on graphing. We're just adding a whole nother piece to this, which is going to be these graphing y-x tables. So take a deep breath. It's the most important part of every math question. You can do this, and let's try tackling it together. If you don't understand everything perfectly on every black diamond, guess what? You're okay. It's still fine to make mistakes during this time, as it always is, just so long as you're practicing, you're learning, and you're staying focused. So let's begin. So our black diamond shows a coordinate grid, which is basically just a blank space like we've been talking about, where we can graph points and show trends. We talked also about how we have been graphing all year in science class on something similar to a coordinate plane, but not with ordered pairs. So far we've been adding in ordered pairs. Now we're adding in these little boxes, which look kind of scary, but they're actually really fun. If you like doing puzzles, you may actually really enjoy this new process. So our first table, notice it has X and Y at the top. That hopefully reminds you of an ordered pair, right? And that's basically all this is doing, is it's telling us this is a list of ordered pairs. So my first one is 3, 6. My second one, we don't have an X, but we have a Y, and that's equal to 8. Our third one, we don't have a Y, but we do have an X, which is equal to 5. And then our final one, we have X is equal to 6, Y is equal to 12. And let's take a look at the board together. Okay, so the first thing we're going to do is we're going to completely ignore this coordinate plane. We do not need to worry about graphing. All we need to do is figure out what is going on with these ordered pairs. So I need to figure out what the pattern is between these. Now, you've been learning about patterns since you were in kindergarten, first grade, second grade, third grade, fourth grade. So patterns should not be new to anybody. In case it is, let me show you an example that's perfect for COVID-19. I am sewing masks for first responders because my husband is a doctor. And then I'm also sewing them for my friends and family and people who need them in our community. I found some fun patterns at Walmart, and so let's take a look at how this would work. So if I had a regular pattern and I had Spider-Man mask, video game mask, and then Harry Potter mask, what would need to come next? The next one in my pattern, if I was repeating, would be Spider-Man mask, video game mask, Harry Potter mask. Whoops. My phone is going off, I apologize. If I was kind of showing this pattern a different way, like a multiplication kind of pattern, I might show 1 Harry Potter mask, 1 video game mask, 1 Spider-Man mask. Now when I repeat it, I'm going to double it. So then I have 2 Harry Potter masks, 2 video game masks, and 2 Spider-Man masks. Now if I was to repeat this again, I would need, give me a second, 3 Harry Potter masks, and so on and so forth, okay? So that's just kind of how a pattern works, just to get our minds in the right mindset of a pattern. Those same patterns can happen with numbers. All I need to figure out is what's my missing cue? How do I get from one number to the other number? So if I'm looking at this, sorry, that was a little dizzy. If I'm looking at this first set, I have 3, 6. What could I do to 3 to turn it into a 6? And we've done a lot of number talks this way, so this should be very familiar to everybody. I could do +3, right? That would work. I could also do ×2. And if I look at it, there's really no one operation other way that I could get 3 to 6. Now I can't check it with this one. I can't check it with this one, but I can check it with this one. Now let me try these 2 operations that I did up here with my other one that's in the blank to see if they work. So is 6 + 3 12? Let's try it. 6, 7, 8, 9. That's not going to work, so +3 doesn't look like a good option for us. Let's try ×2. 6 times 2, is that 12? 6, 12, it is. So the rule for my table, I'm gonna write this in big letters, rule must be times 2, right? My rule here is times 2. So now all I need to know is from when I'm going from x to y, my x is times 2. So then I'm going to go, what times 2 is 8? What could fit in that x spot? 2 times 2 is 4, so that's not going to work. 3 times 2, we've already done that. That's 6, so that's not going to work. Let's try 4 times 2. 4, 8, that works. Let's plug it in. Totally bingo. 4 times 2 is 8. Now 5 times 2 is what? Let's do it. 5, 10. So then my next ordered pair is going to be 10. So now I have my table filled in. All I'm going to do now is take each of these, turn them into an ordered pair or a set of directions, and plot them over here. So my first ordered pair says x is 3 and y is 6. Where did I get those numbers? I'm just pulling them row by row out of my chart. Imagine that each of these charts has an ordered pair. As I do them, I actually like to cross them off. So 3, 6. My 3 is positive, so I'm going to be going to the right 3. 1, 2, 3. My 6 is also positive, so I'm going to be going up 6. 1, 2, 3, 4, 5, 6. I'm going to put my little dot here. My next one is 4, 8. So my ordered pair here is going to be 4, 8. They're both positive again, so I'm going to go over 4, up 8. Cross it off. My next one is 5, 10. So I'm going to go 5, 10. So again, they're both positive, so I'm going to go over 4, 5, up 9, 10. Awesome. And finally, I'm going to do my last one, which is 6, 12. And so I'm going to go over 6. So this is 5, 6. I'm going to go up 12. I'm going to plug my dot in. Now, what you might be noticing, and I can cross it off, is that when I have a rule, at least with just multiplication, or y equals mx plus b if you want to get real fancy with it, these should come together, and if I were to unite them with a ruler, they would make a line. So why is this useful? Well, let's say that this was like weather patterns or earnings or things like that. We could predict, if I know the x, I could then figure out the y, and if I knew the y, I could then figure out the x. That's kind of another skill. Now that we've done this first black diamond on our own, I want you to try the next one by yourself. So use those ordered pairs. How do I go from 3 to 4? How do I go from 4 to 6? And then how can I use that information to fill in the rest? Pause this video and come back when you're ready. So these are our answers. So these are 2 lines that appeared. Our missing blank should be 5 and 10. Awesome. So make sure you've graphed those. If you are a little stuck on that second one, don't worry. All my expectation is that you get this one and that you try something for the next one. So I'm not going to tell you what the rule is because I feel like that would be giving it away. But I want you to try to figure out that second one, try to figure out the rule for yourself, and try to figure out how did I get 5 and 10 as my next answers. All right, moving on. This is our double black diamond. So it's giving us the equation this time, and that now we need to figure out how we would graph it. Now, if this is like a 7th grade math skill, so if this is feeling a little bit hard for you and you were still stuck on the black diamond, feel free to skip this step and instead do an extra 10 minutes of IExcel. If you'd like to skip that, you can do the double black diamond with me. So my first equation, and this is why we have the y equals mx plus b. So we have y equals x plus 2, okay? And so how I figure this out, now I know the rule. I just need to plug it back into a table. So if I have my x and my y, so make myself a table. It's kind of step 1. Step number 2 is to pick some easy x's. Now, I know some of you are super creative and you're going to try to put numbers like 48 and 62 because those are your favorite numbers, but no. We're going to try to stick with easy numbers. That is the trick to these double black diamond questions. So let's say you want x to be 0, 1, 2, and 3. Okay? So now we're going to try to figure out what y is using each of these numbers and plugging it in. So what would y be if x was 0? So if x is 0, 0 plus 2 is 2. So y would equal 2. If my x is 1, I'm plugging it in up here. 2 plus 1 is 3. So if my next number is 2, if x is 2, 2 plus 2 is 4. And if x is 3, 3 plus 2 is 5. So now I have my next set of ordered pairs. Now I can take these ordered pairs and put them onto a coordinate plane. So my first one says 0, 2. So I make that into an ordered pair. So my first ordered pair is going to be 0, 2. So I'm not going anywhere on my x-axis, but I'm going up 2 on my y-axis. My next one says 1, 1, 2, 3. So I'm going to put that in place. My next one says 2, 4. So I'm going to go over 2, up 4. And you're probably seeing already that this forms a pretty easy line. So whether you have your Ultimate Math Notebook at home or not, please try to finish the rest of these questions. That third one is a doozy. Know that if I multiply -2 times x, so if I multiply, and we didn't even talk about multiplying negative numbers, which I wish we would have. So this one's a super challenge, but if you're up to it, so if I multiply -2 times 1, if I multiply a negative times a positive, my answer is still going to be negative. So it's -2 times 1 would be -2. So it's all the same thing, just adding in that negative as long as the second number is positive. That was a lot in a short amount of time. Make sure you rewind, rewatch, and ask any questions that you have as you're solving. If this is really confusing, take a deep breath. My expectation is not that you get this with 100% perfection. My expectation is just that you're being exposed to a few new ideas and are able to put those into practice. Thank you so much for joining me, and I will see you tomorrow, or for science. Sorry.